Okay, 2.2. 2.2 graph of function. Graph of functions. So in the previous section, we learned how to graph an equation. We're going today for graph of function. It's similar to the equation, but there is some points are different. First things we have to graph. Let me give you the definition how graph the function. So graph of functions by plotting points. Okay, so what does that mean? We have to plot the points. This is mean. This is mean. I have to plot the points. To plot the points x comma f of x, then in the Cartesian plane or the coordinate plane. Plane. Since x here is the input of the function, and here is the output of the function. So this is the input, there is the output. We plot, we get the order pair of the point like this. We show it in the coordinate plane. Okay. So this is the input of the function. This is the output of the function. And last time I give you some name, I give you types of function. So first one is called a function of the form f of x equal m times x plus b. This is called a linear function. Is a linear function, so that m here is the slope, and b here is the y-intercept. This is review from last classes. Second type of the question of the function, a function of the form f of x equal b. Since here the slope is 0, it's look like this equation, the linear equation, but here the slope is 0. They give me f of x equal b. So this is a constant function. It's called a constant function. And the draw for these things is a horizontal line. When the slope is 0, like last time I said, when the m here is equal 0, the slope is 0, the draw is a horizontal line. It is the line. A third type of equation, or function, sorry, a function of the form f of x equal x to the n is called a power function. It's a power function. Here we got off. And function of the form like this, a function, the form f of x equal x to the power 1 over n, and n not equal 0 is a root function. So this is type of function, linear constant power root function. Now let me give you an example how to graph a function. Graph the function. So I'm going to graph 3 functions here in this slide. First one, second one. Okay, so the first function here, f of x equal x squared, where f of x equal x to the power 3, f of x equals square root of x. So the question is graph the function by plotting points. So here, like I said last time, we have to choose a random values, x, f of x, and here the point x comma f of x. So who will give me the random values here? I need negative numbers and positive numbers.
-2, -1, 0, 1, and 2.
Perfect, nice. So I'm going to choose -2, 1, 0, 1, 2. Who will do the first one? -2, plug it inside the equation, the function, sorry. I need the answer direct.
4.
4. So the first one, when you plug the -2 inside the function, -2 squared, they give me 4. Second point.
1.
1. Third point.
0.
0. 1. And for the 1.
1.
1. And for the 2.
4.
4. You just plug the point inside the function here, and then I get another point here. The order pair for the point is -2 and 4. Second point is -1 and 1. Here is 0 and 0. 1 and 1. And here is 2 and 4. Then I have to draw the coordinate plane.
It will be a parabola.
Parabola, exactly. So let's do it together. So again, this is my y-axis here, and this is my x-axis. At 0, 0 is here. At 1 and 1 is in which quadrant? 1 and 1. Which quadrant? First one, second one, third one, fourth
Second.
one. Which one?
Second.
And just 1 and 1, it's in the first or second or third or fourth.
First.
1 and 1. First. So here is the 1 and this is the 1 here. So the point would be here. 1 and 1. 2 and 4. Which
First.
quadrant? First. So this is 2 and here is 3. 1, 2, 3, 4. So like it will be like around here. Same things for negative and 1 and 1. So where is the which quadrant?
Second.
Second. So this is my negative 1 and 1 here. And negative 2 and 4, which quadrant? Negative 2 and 4.
Second.
Second again. So it will be like around here. Around here. Negative 2 and 4 here. So the graph, it's look like this. Something like that. So this is the function f of x equal x squared. Any question for the graph for the first one? Okay, let's do the second one. Who will give me the points for the second one? F of x, and x comma f of x.
The same. -2, -1, 0, 1, and 2.
Nice. Same points. We'll choose. Okay. So first point is -2, -2, -1, 0, 1, and 2. Now again, you plug inside the equation, -2,
-8.
-8.
-1.
-1 again,
0.
0, and the 1, and 2,
and 8.
8. The point here is -2, comma -8, -1, comma -1, 0, comma 0, 1, comma 1, 2, comma 8. Same things. We draw the quadratic plane. Now, at 0, 0 is 0, 0 here. So here is 0, 0. First point here. Second point, 1 and 1 to be like around in the first quadrant. This is the point 1 and 1. At 2 and 8 would be like here 2, and 8 around close to here, like around here, like around here. Now in the -1 and -1, this is -1 and -1 around here. -2 and 8 will be like around here, something like that here. So the jaw for these things will be like around something like that. And here, something like that. So the point will be like here. Second point is here. Okay? And don't forget the arrow because it's goes to infinity. And here is the y-axis. And here is the x-axis. Any question for the second one? Okay, let's do the third one. How to graph the third one. So again, we have to choose random point, x, f of x, x comma f of x. Which point would you like to use here? Which point would you like to use? Which point would you like to use? Who will give me a suggestion? Which point? Can I choose negative numbers?
No, I'm gonna use negative numbers.
Yes, so we cannot here plug negative numbers inside the radicals of root 2. I said if we have root 2 or 4 or any even number, cannot plug inside negative. So which point would you like to use? Any positive numbers, like 0, 4, 16. And this is easy point because I know what's the answer. I mean, not 16, I will use 9 and here 16. This is easy point because when I plug it, I know what is the answer. Okay? I cannot plug negative numbers inside the radical because it has an even root. Okay, what's the radical of 0? Where's f of 0? When you plug the 0 inside the radical, what's the answer? What is f of 0? It's 0. What's f of 4? What's this? 2. What's the 9?
3.
3 and 4. Square root of 16 is 4. So the point is 0, 0, 4 and 2, 9 and 3, and 16 and 4. So when you graph something like that, you have, let me take the pen. So now 0 and 0 here. This is 0 and 0. 4 and 2 is like around here. So like around 1, 2, 3, 4, like around here. Let me choose the 1. I forgot the 1 here. Okay, let's take the 1 too. Instead of 16, I'm going to use the 1 because the 1 has the answer. Okay, let me use the 1 here. 1. So what's the square root of 1? Is 1, 1, comma 1. Okay. So 1 and 1, 4 and 2, like around here. And just you continue the graph. So the graph will be look like this, something like that. Here, let me move it down a little bit. So the point is at 4 is 2, like around here. So this is f of x equals square root of x. Any question for the 3 graphs? Makes sense how to graph? Again, this is my y-axis. This is x-axis. Now, other kinds of a graph, we have to graph the piecewise defined function. Like we have piecewise equation, we have also piecewise for function. So graphing piecewise defining the function. Defined function. What is the meaning of piecewise function? Like equation, what is the meaning of piecewise function? Okay, let me remind you. Piecewise function means a function with inside more than one function with different domains. Okay, like for example, graph the piecewise function, piecewise function. So the function, the piecewise function look like this: f of x equal like f of x equal x squared and 2x plus 1. Here for the domain x less than or equal 1, and here for x is greater than 1. So this is piecewise function because a function has inside two functions with different domain. So to draw a piecewise function here, we have to draw this one, making a table for this function. We're making a table for the other function. Then we join this the graph for the first one and the second one in the same coordinate plane. Okay. So we're making a table for f of x equal x squared. Then we make a table for f of x equal 2x plus 1. Then we have to draw the graph for both of the functions. This is the graph for both of the functions. Okay, let's do the first one here. F of x equal x squared. Again, like we're using our tables. So let's choose a point here, x, and f of x, and a point x comma f of x. The same like before, x squared, f of x equal x squared, and we're going to use this table again, but for like domain x less than or equal 1. Okay, I have to use this domain for graphing this function. What does that mean? This means I have to start from the 1, then I have to choose any number less than 1. So I start from the 1. What is f of 1? When I plug the 1 inside the function, what is the answer? What is f of 1?
1.
1. Square root of 1 is 1. So the answer is here 1. So the point 1 comma 1. For the 2, because the 2 is a greater, no, not the 2. I have to choose number less than 1, like 0.
-1, -2.
Yes, exactly, -1, -2, -3. So what's the, when I plug the 0, what they give me? F of 0 is, f of 0 equals 0 squared is 0, yes. So the point is 0, 0. For the -1, plug the -1 inside the function. -1 squared is 1. So the point is -1, 1. For -2, f of -2 is equal -2 squared. What is the -2 squared? What is the -2 squared? 4. -2, 4. For -3, plug the -3 inside this. I get 9. -3, 9. So we're going to use this point to graph the first function. For the second function, let me make a table again. Okay, second function, x, f of x, and x comma f of x. So again, we have to use, by starting from the domain here, x greater than 1. So I have to write 1, but this point I have to put start. This is mean not in the domain. Okay? Star means is not inside the domain, because the answer here, the domain is greater than 1. So what's f of 1 after we plug the 1? When we plug the 1 here inside this function, what is the answer? 2 times 1 plus 1.
3.
3. So the point is 1, 3. Give me like random points is greater than 1.
2.
2. And what else? 3, 4.
5.
Here I get the question. if it is greater than 1, do we have to use 1? Yes, we have to use 1, but I put here star. This mean is not inside the domain. But when we draw it, we put open circle. I will show you in the graph. For the 2, what is the answer? 2 times 2 is 4 plus 1 is 5. 2, 5. For the 3, 2 times 3 is 6 plus 1, 7. For the 4, 2 times 4 is 8 plus 1, 9. 4 and 9. Now we have to graph the both of the function inside with using the same coordinate plane. Now let me start from graphing this function. 1 and 1. Because the 1 is inside the domain, we put it as a circle, closed circle. So this is 1, 1. 0 and 0. It will be look like this. -1 and 1. Here's -1 and 1. -2 and 4. Here is -2 and this is 4. Now graph the second function. At 1, 1 and 3. Here's the 1 and here is the 3. So 1 and 3 is open. Why? Because it's open because it's not inside the domain. 1 and 3 is not inside the domain. We got it open. At 2, 2 and 5. This is 2 and here is the 5. It will be like around here. And the same things for 3. 3 and 7. So actually the graph will be look like this. From this point, like this. At 3, they give me 7. So this is 3. Here's the point. And here is the 7. And here is 2. And this is 5 here. So you know how to draw now the graph? It's clear for everyone?
Yes.
Okay. Again, this is my y-axis. Here's the x-axis. Okay, another question, how to graph the absolute value function. Can I move to next slide, or it's any question for this example? Okay. So another example for piecewise function is the absolute value. Example, graph f of x equal the absolute value for x. So what's the absolute value function? What's the definition for this function? From previous sections. I give it one time for previous classes. What is the definition for the absolute value function? Okay, let me remind you, it's x and minus x. It will be x if the number is positive, greater than or equal 0. And it will be negative if x is less than 0. So this is the definition for the absolute value function. Now, to draw this function, we have to do the same idea like previous example. Two pieces of the example. So the first one, we have to take the function of x equal x. Second one, of x minus equal minus x. Okay, same idea. F of x equal x. F of x equal minus x. So the same things, x, take point f of x, and the point x come off f of x. Same things here, x, f of x, the point x comma f of x. Okay. So now we'll go to the domain for the function f of x equal x. Here they ask me for all numbers greater than 0. So I start from 0, okay? What's the number greater than 0? Like 0. What else?
1,
1,
2, 3.
2, 3, 4. What's the answer for what's f of 0? Plug this inside the function. It's 0. What's the point? 0, comma 0. For the 1, plug inside the function. It's 1, 1, comma 1. For 2, same things. 2, comma 2. 3, the same things is 3, comma 3. Same things for 4, 3, 4, comma 4. Now for the second function, what is the domain for the second function? What's the domain for the second function? Or who will give me the value for the second function?
Isn't it all real,
What is it?
all real numbers?
Or real but we started from where?
From 0 to positive infinite.
To positive, no. Negative infinite, exactly. From the 0 to the negative infinite. Why all the numbers is less than 0. So will give me the points. So we start from the 0 again. Put 0. But I put star here. This means the 0 is not inside the domain. -1, -2, -3, -4. Now plug inside the equation, inside the function. So what is the f of 0? Is 0, exactly. What is the f of -1? What is f of -1?
1.
1. -2, same things, 2. -3 is 3, -4 is 4. Just plug inside the function. So the point is 0, 0, negative 1, 1, negative 2, 2, negative 3, 3, and negative 4, 4. So now we have to draw the plane, and we have to apply this point inside the plane, inside a Cartesian or coordinate plane. Okay. Okay, let me draw the plane here. So again, the 0 is 0 will be look like, I will start from this function. 0, 0 will be here. 1 and 1 will be like around here. 2 and 2 will be like around here. 3 and 3 will be around here. Okay. So the graph, it will be like, I will draw by using the red color here for the first function, like around here, like something like that. So again, 0, 0 here. This is 0. Here is the 1. 1 and 1. 2 and 2. This is 2. This is 2. And the same things for 4 and 5 and 6. 3 and 4 and 4. 3 and 4. So this is my function of x equal x. For the second function here, the 0, 0 is not inside the domain, but it's already inside the domain in the first function. So we keep it circle, closed circle, or bold circle. So again, the graph for this function, it will be like around something like that. Again, we use the point 0, 0 is the same 0, 0, but it's not inside, but it's already bold. -1 and 1. So this is the -1 and 1, like around here. -2 and -2 and 2 be like around something like that here. -3 here, and the same things for -4, something like that. It is open circle. No, it's open circle, but the red circle is closed, so we keep it closed. So it'll be like a closed point. Okay. Anyone has a question? So the red one and the blue line is exactly the function f of x equal the absolute value for x. It is the black, this the piecewise function. Okay. Here the y coordinate, axis, the x-axis. Any questions so far? It is clear how to graph a piecewise defined function. No questions?
Can you do another example, but like more complex?
Like more complex?
Yeah, that's not a line. Just like 3x squared minus 5. I don't know, something like that.
Like what? Give me.
Just something that'll be on the test.
Okay. Okay, let me give you like x cube plus 1 and here 2x. Is good? Here when x is greater than 1, x less than 2. So the same things, same idea. F of x equal x cube plus 1 and f of x equal 2x. We pick the point starting from 1. So this is x, f of x, and x comma f of x. Same things here, x, f of x, and x comma f of x. Which point would you like to use from the 1? So let's start from the 1 itself, and it's not inside the domain. Give me any number greater than 1. So 1, 2, for example, 3, 4. Now for the second function, f of x equal to x, starting from 2. So the 2 is not inside the domain. 2, I put like stars. Any number less than 2, like 2, 1, 0, minus 1, minus 2. Okay. Now, plug the 1 inside the equation. 1 cube plus 1 is? What is 1 cube plus 1? 2. For the 2, 2 cube plus 1 is? 2 cube is 8 plus 1 is 9. For the 3, 27 plus 1, 28. For the 4 is like, will be like, give me like large number. So we're not going to use it. Now the point is 1 comma 2, 2 comma 9, 3 comma 28. For 2 here, 2 times 2 is 4. For the 1 is 2. For the 0 is 0. For minus 1 is minus 2. For minus 4, for minus 2 is minus 4. So the point is 2 comma 4, 1 comma 2, 0 comma 0, minus 1 comma minus 2, minus 2 comma minus 4. Now we will draw the Cartesian plane and you plug the points. Okay, for 1 and 2 is here. This is 1 and here's 2. So this is 1, this is 2. This is open circle. And 9. So this is 2, and 9 will be like here, around here. Closed circle. 3 and 28 will be like around here, up. Let me remove this a little bit to the right, so it will be like around something like that here. So the first graph will be look like this, something like that. Something like that. First graph for x squared, x cubed plus 1 would be like, look like something like that. This point, I worked like around 9. This is the first graph for the function f of x equal x cubed plus 1. Now for the second function, it's a line to x, like look, 2 and 4. One and 2. So 1 and 2. 2 and 4 is not inside. Hold on, here we have to choose to change the domain. X greater than 1 and x less than 1 here. Here, I'm changing the domain because it's not giving me a function. So less than 1 and I put it equal. So this is mean we don't have the first point. So here less than 1 and equal. Now it's a function because before it's not a function. So we don't have need this. Now at 1, it's inside the domain. So 1 and 2. So this is 1 and 2. So because it's 1 and 2, it's inside the domain of the function will be closed. We close it. 0 and 0. This is 0 and 0. Minus 1 and 2 and minus 2. So this is my minus 1 and minus 2 is down. So the graph for the other function will be like something like that. Well, here minus 1 and like here it's the negative 2. So this is the second function of x equal to x. Axis, x-axis. Any question for this one? Makes sense? How to graph? All the piecewise function, it's similar to the same idea. You draw the first function, second function, and you draw both of the function, we were putting both of the functions inside the coordinate plane. Now, let's go to the vertical line test. Vertical line test. What is the meaning for that? This is mean, how can I check the graph of the function, the graph of the coordinate plane, is a graph of function or not? So I can check now, is the graph of the coordinate plane is the graph of function or is not a graph of function by using the vertical line test. So here I can set the curve in the coordinate plane is a graph of function only, or if and only if and only if no vertical line intersect the curve more than one time, more than once. What does that mean? For example, let me give you example and explain what does that mean. So example, if I have a graph look like this, my graph look like that here. If my graph look like this, so the first graph, it is like something like that. And my second graph, it is something like that. So to check now the graph, to check now the curve here, it is a graph of function, we have to use the vertical line test. Or this curve, it's a graph of function, we have to use the vertical line test. What is the vertical line test said? Said if I have, for example, line, and this line intersect the curve in one time. Look, if I move this line, look, I'm moving this line, and this line is intersect the curve just at one point. Look, the vertical line intersect the curve at only one point. This is mean this curve is a graph of function. So the first one, look, at every point, intersect the red line vertical line test, the vertical line at only one point. So this is mean this curve is a graph of function. So the first one here, this is a graph. This is a graph of function. Why? Because the vertical line test intersect the curve and only at one point. Now, for the second graph, if I have a vertical line, and look, this vertical line intersect the curve at 2 points. Look, the vertical line intersect the curve at 2 points. So this is mean this curve is not look like a graph of function. So this is not a graph of function. Why? Because the vertical line intersect the curve at 2 points. Look, this is the first point, and this is the second point. Any question for that? Yes, Angel. Cannot repeat, yes. Anyone has a question? How to do the test, the vertical line test? Okay, let me draw another line here by the red, and I show you again the line, the vertical line, cross the curve at 2 points. So this is the first point, and this is the second point. This is mean this curve is not a graph of function. Okay, let me give you more example. Which of these curves are a graph of function? So the example now, which of these graphs is a graph of function? So the first one, it's look like this. Second one is like that. Fourth one, something like that. Last one, something like that. Okay, for the first one, who will do the first one? Is it a graph of function? The first one, who will do the first one? Who will do the first one? Is a graph of function by using the vertical line test?
It's not a function.
It's not a function. Why? Because if we're using the vertical line test, look, this is my vertical line test, the blue one. The blue line intersects the curve in 2 points. Look. So this is mean is not a graph. It's not a graph of function. For the second one, who will do the second one? Who will you say yes? Who will say no?
Yes, it is a graph of function.
Yes, it's a graph of function. So here it's no, the first one is not a graph of function. Second one, it's a graph of function. Why? Because if I draw like the vertical line and I move in this line at all the at the curve, I see this line intersect the curve at only 1 point. Look, only 1 point. So this is mean it is a graph of function. So this second one, yes, it is a graph of function. For the third one,
it's also a graph of function because it passes the vertical line test.
Exactly. So it's passing the vertical line test. It's also a graph of function. Let me show you. So this is my vertical line. And again, it's intersect the curve at 1 point only. So yes, the answer is true. For the fourth one, we'll do the fourth one.
It's not because it doesn't pass the vertical line test.
Exactly. It's not passing the vertical line test. Why? Because this is my vertical line test. It's if we're moving this line at the curve, it shows intersect the curve at many points. It's not at only one point. At this point, this point, this point, this point. This is mean. It's not a graph of function. Any question for this for example? Okay. Now, let's go to the question, which equation represents a function? Now, after we look into the curve, the graph, we know which graph represents a function. Now, we're going over which curve, which equation. So now, which equation represents a function? Which equation represents a function? Okay, who will remind you the definition of function? What is the definition of function? What is the meaning of function? Or what's the important property for function? What is the definition of function? Okay, I think, okay, let me remind you. So function here means like every input must have only one output. This is the most important property for the function. Now, to check the equation is represent a function, we have to check this property. Is this equation, if I plug any input, they give me one output? Okay, let me give you an example for that. So the example is, does the equation define a function? So the first equation is 1, y minus x squared equal 2. Second one, x squared plus y squared equal 4. For the first one, this is an equation. Represent a function. Okay, let me give you an idea how to do this. So first things we have to solve this one in terms of y. Means we have to make y equal. We have to make the equation y equals something. So solve in terms of y. So what is the solving of term of y? How can I solve this one in term of y? What we have to do?
Add x squared to both sides to get y by itself.
Yes, true. We have to add x squared to both sides. Then what I get? Get y, capital Y equal x squared plus 2. Now this equation, if I plug any number inside this equation, they give me only one output, one solution. For example, if I choose the 0 plus 2, they give me 2. If I choose any positive number, 1 plus 2, they give me only one answer. 1 plus 2 is 3. If I choose 2 squared, they give me 4. 4 plus 2 is 6. This is mean if I plug any real number inside this equation, they give me only one output, one solution. This is mean I can represent this equation as a function. So yes, I can represent y equal x squared plus 2 as a function. Is f of x equal x squared plus 2. For the second one, who will do the second one? The same idea like the first one. Who will do the second one?
Y equals negative s squared plus 4, everything squared.
So again, y equal what?
Y equals square root of negative s squared plus 4.
Negative, okay, negative x squared or 4 minus x squared. But hold on. So can we do it step by step? Angel, can you show me how we do it?
We should try s in both sides, s squared in both sides.
Okay, I get what? 4 minus x squared, right?
Yes, and then we square root y in both sides. We take the
Square
square root in both sides.
But when we take the square root for both sides, I have to choose positive, negative, right? Don't forget that. So I get positive, negative, 4 minus x squared. Okay, so now look, y equal positive, negative, square root of 4 minus x squared. This is mean if I plug any number inside the radical, they give me two solutions. The first solution is positive, the radical, and the second solution is negative, the radical. And what does that mean? Can I represent it as a function? Can I represent these things as a function?
No, because you have those two solutions there.
No, exactly. So cannot represent this as a function. So now cannot represent y as a function because for every input has two outputs, and this is not a function. Make sense? Anyone has a question for this? Anyone has a question? How to think this equation is look like a function?
Now it's clear.
No questions? Okay, if there is no questions, this means this section is finished. 2.3 is finished. Now let's go to the 2.3. 2.2 is finished, the graph of function. Now let's go to the 2.3. Is getting information from the graph. So now I can get information from the graph of the function. Okay. So now, first of this section, starting as values of function, domain and range. We will talk about the domain and the range. So values. And domain and range. So let me give you example as at the beginning. And by the example, I'll explain the idea. So first things we have to do graph. The graph like this. We have points here. Have 1, 2, 3, 4, 5, 6, 7. 1 is 5, 10, 15, 25, 20, 25, 30, 5, 10. This is 5. Here is 10, 15, 20, 25, 30, and here is 35. Here is 1, 2, 3, 4, 5, 6, 1. So at 1, here, at 2, is like here, 3, here, at 4. Something like that. At 5. At 6. They give me something here. Okay, and don't need this. The graph, something like that. Goes up. Something. Something like that. Okay, now the question is, by using the graph, find, first step, find the value of f of 1, f of 3, f of 5. Second two things, which is the larger? Which is larger? Okay, let's do step by step. For the first one, who would do the first example? Find f of 1. What is f of 1 from the graph?
25.
25. How you found it?
I look for the S value on the bottom and then go up all the way up to the
Exactly.
line.
And he go up from the 1 here like this, and he intersect the graph at this point. This point is 25. So this is mean the value for f of 1 is 25. F of 3. What is the f of 3? Same idea. Here is the 3, goes up, you intersect the curve at this point. This point is 30. So the value is 30. For f of 5, who will do the f of 5? Give me estimate for f of 5.
It's 17.
Like around 17. Yeah, if you go up here, it's like between 15 and 20, like around 17. So will be like 17. Perfect. So question number 2. Question number 2. Which is larger? Which is larger? F of 1 or f of 5?
F of
Which
1.
is larger, f of 1 or f of 5? F of 1, why? Because like from the previous one, f of 1 is 25 and f of 5 is 15. So f of 1 is 25, is larger than f of 5 is equal 17. Okay, so f of 1 is larger. So which is the larger is f of 1. Third question. So number 3. Find the value of x for which f of x equal 25. The question is, find the value for x for which f of x equal 25. Who will give me the idea how to find the values for f of x equal 25?
We look for the y value where it is 25. Then we go horizontally to the right and we check there's values there for the line horizontal test,
Line.
we can call it.
Yeah. Yes. Exactly. So the question is, find the value for x for which f of x is equal 25. So this is me, and I go to the 25 here. Then I draw a horizontal line, and I check which point are intersect this horizontal line with the curve. So this point that intersect the horizontal line with the curve is this point. This is the first one at 1. This is the second point. It's 4. So this is the first one, the 1, and the 4. Okay. So which is the value for x for which value of x for which f of x equal 25 again is 1 and 4. Any question for this? Okay, example number 4. Find the value of x for which f of x is greater than 25. Need to find the value of x such that f of x is greater than 25. What is the value for x? So again, this is the 25. I draw a line. I need all the value such that this value will give me greater than 25. What is it?
2 and 3.
2 and 3, it's right. What about 1?
Greater than? No, because it's just equal to, right?
Oh, we don't have equal, right? So what about 2.5? 2.5 here, this point.
Yeah, I think it's all numbers between 1 and 4.
Exactly. This is exactly. So find the value for x for which f of x is greater than 25. It is all the number between 1 and 4, because 1 and 4, all the numbers is greater than 25. This is 25. All this value is greater than 25. This is mean the x will be from here to 4, all this value except the 1 and 4. Why? We don't have equal. We don't have equal here. So the answer will be the open interval 1, 4. Make sense? Any question? Okay, example number 5 now. Find the net change. The net change. Change from 1 to 3. What is the net change formula? What's the formula for net change? The formula, let me remind you, it is f x2 minus f of x1. This is my x2, this is my x1. So f of 3 minus f of 1. What is f of 3? Family graph. Here is the 3. What is f of 3? Is 30. This is the point, is 30. Okay? So f of 3 is 30 minus f of 1. What is f of 1? Here's 1. They give me what? 25. So here f of 1 is 25. What is the answer? It's 5. Okay, any question so far about this example? Any questions so far about this example? Okay, if there is no questions, I'm going to stop until here today. Okay, and I see you next time.